We are going to now delve into the architecture for Hadoop itself. Let us begin by understanding the key attributes that define Hadoop. First, Hadoop is accessible. The technology is readily available and it is inexpensive. For example, most of the software comes from Apache open source software and it comes with a free license. It is robust, which means that it's high availability and fault tolerance built in by operational design. It expects and manages a high number of hardware and or software failure. It is scalable, and I do mean massively scalable. It will scale horizontally to tens of hundreds to even thousands of data nodes. And in many ways, it is very simple. It provides an elegant, simple interface for the developers and the clients that abstract away the complexities of supercomputing. Now, we're going to define Hadoop itself. And the first thing we want to do is define Hadoop into three separate components. There's HDFS, Yarn, and MapReduce. HDFS is the Hadoop Distributed File System, and it maps into the data repository layer of our big data architectural stack, while Yarn is the parallel processing framework, and it is really the heart of our data refinery. MapReduce is a subsection of the data refinery that handles parallel processing for particular types of MapReduce jobs. This is another mapping which I encourage students to memorize. It does a great job of showing all the components for Hadoop. For HDFS, it shows the key daemons, which are the name node and the data node. And for Yarn, it shows the resource manager, the node manager, and the application master daemons. It also shows the servers where each daemon resides. The master server runs the name node and the resource manager daemon, while the data server runs the data node, node manager, and application master daemons. Let me give a more detailed view of the Hadoop Distributed File System, HDFS. Let us start with a few key learning elements. The first and most important thing to learn about HDFS is its purpose. HDFS abstracts away the complexity of distributing large data files across multiple data nodes. The name node keeps track of all the data files throughout the Hadoop cluster. Now, HDFS works best with a single large file, and we do mean large file. A data file of 60 terabytes is easily handled. Such a large file must be split up and the segments sent to different data nodes. We call these segments data blocks. In HDFS, data blocks can have standard sizes of 64 or 128 megabytes. They can be made even larger by changing a configuration parameter. HDFS is basically a write-once file system. The normal sequence is for lots of small data files to be created elsewhere, and then all these data files merge together into a single large HDFS file. These HDFS files are then ready for analytics. HDFS is not a good system for storing data that needs to be constantly modified. And our last architectural principle that we want to discuss in regards to HDFS is embracing failure. It is one of the most important attributes of HDFS, and it is founded on data replication. The number of copies of a data file is a configurable parameter, but it is normally left at the default value of 3. The system does a princely job of distributing the data across many nodes at load time. HDFS then does an analysis and makes multiple copies of each data block. HDFS is very astute at alerting to the loss of access to a data block, and when this happens, HDFS begins replicating another data block to always keep the number of copies to the replication level, typically 3. This is high availability and fault tolerance by operational design. The Hadoop Distributed File System uses the following servers. There's a master server, a data server, and typically a backup server. The master server runs the name node and is responsible for the management of the data throughout the cluster, while the data servers run the data node and are responsible for managing the data on their local server. The backup server is used as a backup for the master server, and its purpose is to increase our high availability for the master server.